What's up, everybody? It's Brian from Tuner Tools. I want to give you a quick practical example and show you how to set up in the software some advantages with using a PDM. Again, I've talked about how a PDM is more than just replacement for your fuses and relays and why there are performance benefits to using a PDM, performance, reliability, just overall robustness of your system. If you're running a race vehicle, you absolutely should be running a PDM of some sort. One of our go-tos is the ECU Master PDM. I'm going to show you why. So what I've got here is we've got a blank project inside the ECU Master PMU client, and we're going to set up fuel pumps today because that is a great example of something you can do with a PDM that can save your engine, can save your race car, can keep you on track, and you can actually finish a run without even knowing your fuel pump died. Keep you going, keep you on the track, keep you from getting put on the trailer because of some stupid little problem. So what we're going to start with is defining an ECU. Now in this case, we're going to treat this like this is a Formula Drift prospect car where we have to run a link ECU. So let's start by defining a link ECU. And it's really easy inside of the ECU Master software to use many different manufacturers' ECUs. They've predefined a bunch of different ECU software here. You want to start by importing a CANX file or a DBC file. And this is just sort of a translation file of telling the PMU software how to expect the data from the ECU. In the case of link, we're going to use this link ECU generic dash.canx. The generic dash is what it's transmitting from the ECU. If you go into your link ECU and go to your CAN setup, there's going to be a transmit generic dash. That is going to be the protocol that the ECU Master PMU is going to be looking for. So you need to make sure to turn that on in your link ECU. And a couple things to check for here. First, make sure you're on the right CAN channel. There are 2 CAN channels on most of the PMUs, and you may not be transmitting to the correct one. Now, this is the CAN channel we're using on the PMU. You also need to make sure that you set up the correct CAN channel output on your ECU because the link ECUs also have 2 CAN channels. The other thing is the base ID, and there are 2 places where this kind of catches people out. One is just making sure the base ID matches. The other is making sure that you're matching it correctly, and this is where this hex is going to come into play. There are 2 different ways to defining CAN IDs. One is hexadecimal, and the other is decimal, and that's just base 10, base 16, hence the hex. So one thing to remember here is that numbers may not look the same in each, and in this case, we see this 3E8. If you go to link, they're going to tell you that their default for their transmit generic dash is ID 1000. That's because link uses decimal. In hexadecimal, 3E8 is the same as 1000. There is a translator you can use. I like to use rapid tables. There's a bunch on Google. You can just search hex to des, des to hex. Those come up. We can kind of go through that and how that works, but just make sure that you are using the correct number and the correct format, and realize you might have to translate between different formats to make sure you have the correct number. The next thing to do is just select the CAN channels you want. You can select individuals just what you want and not have everything. In this case, there's not a lot of channels here. We're going to go ahead and select all of them, and we're going to click OK. Now what we've got is our ECU channels defined inside of our PMU. We can now see all of the data our ECU is transmitting to the PMU and use this to go ahead and set up our pumps. So the first thing we actually need to do before we set up our pumps is set up some keyboard logic or some switches. In this case, I tend to use CAN keyboards. I really recommend them versus physical switches. And the first thing we're going to need is going to be an ignition switch. I'm going to give it a picture. I like to do this one so I can assign my keyboard buttons correctly, and the other is so I can just visually make sure that my description inside of my software matches what I'm actually assigning to it. I'm also going to define a fuel pump switch. In this case, we are going to do a multi-state switch, and it's going to have 4 different states. I tend to do that as 1 off, 3 on. And we'll go through why that in the future. And let's give that a picture real quick. All right, so what we've done is we've defined our keyboard. We've got an ignition switch and a fuel pump switch. We've brought our CAN data in, again, using this button here, the import CANX DBX, the keyboard button here. Now we're going to start actually defining our outputs. In this, we use power output. So in this case, we're going to treat this like it's sort of a typical drift car with a surge tank. In this case, let's treat it like it's, say, a Turbo JZ with 3 pumps in the lift tank, 3 pumps in the surge tank, and a lift pump. And in this case, let's say we only need 2 pumps to run the engine, but we've gone ahead and installed a third. That's a spare or a backup, and that's where the advantage here is really going to come from. So first, we're going to define the lift pump, and we're going to give it an output. We're going to give it some basic settings here, and it's important to make sure that these are set to be appropriate to what your pump draws. Don't just go off the, oh, I use a 30 amp fuse, so this needs to be 30 amps. Most pumps aren't going to pull nearly that. It's the inrush that causes you to need that big of a fuse. We can have that conversation in a different video, but just make sure that these settings are correct for your pump. If you need help with that, definitely hit us up and we can help you set these up. We do offer design and consultation and PDM setup for customers, whether you buy the PDM from us or not. It just depends on what we charge for if you bought it from us or not. And there is, if you do buy it from us, we do offer a certain amount of free setup. So definitely take advantage of that if you buy your PDM from us. And we'd be happy to chat about your project even before you buy the PDM from us and give you some free advice. But for now, we're going to set up a fuel pump. The first thing we need to do is make it prime. If the ECU has a fuel pump status output, it gives over CAN. That's a real easy way to do that. In this case, we don't have it. We could go define it, but we're going to try to keep this easy. And the way I would do this when I don't have that, so we're going to use a formula here, and this is how you use logic inside of an ECU Master PDM or inside an EMU Pro ECU, an ADU, or most of the ECU Master products. In this case, to prime it, we're going to use pulse. Now, it sounds like we're going to pulse it on and off, and that is sort of true. That is what a prime is. We're going to only pulse it once, so it's going to be a single pulse, and we're going to give it a certain amount of time. So we're going to prime it for 3 seconds. So it's a single pulse for 3 seconds on the rising edge, which is when this function becomes true. And if you remember, we defined that ignition switch. This is going to be what turns on our ECU. So the same as hitting your key on your car or something like that. Whenever the ignition switch turns on, rising, we're going to pulse the pump once for 3 seconds. So we're going to prime it. So that's going to prime our system. Now we still need our lift pump to run whenever the engine is running. The easiest way to do that, and the most common logic, is to use RPM. Because that means that the engine's turning, it's cranking over. It's actually making sure that we're detecting that the engine is turning over. I like to use something more than just not zero. That way someone turning the engine over by hand or some noise or an issue with your crank sensor doesn't cause it to constantly turn the pumps on and off. I'm going to use 80 in this case. It's probably a little low. Kind of get a good idea of what your cranking threshold is and make sure you have a little bit of a margin to that. So if I'm only cranking at 100, 130, I might leave it at 80. If my engine cranks at 300, I'm probably going to make this 100, 120, something in that range, just to make sure that I have a proper margin there. I'm also going to give it a little bit of a false delay. In this case, we're going to go with, let's go with a quarter second on the lift pump. And this just makes sure that it has a little bit of a delay and just a little bit of a drop doesn't cause it to stop running. There's a couple different reasons for that, but it's really just to make sure that there's a smooth operation and there's not a lot of on and off switching of the pump in some odd situations. So this is really going to be the basics of what we need to run it. We're going to add one extra little thing here, and that's going to be our switch. So if you remember, we added a fuel pump switch, and this is an override switch. That's not something you have to do to run your pumps. But if I want to choose to run my pumps, whether to force them on, whether it's for safety, whether I don't know if they're running, I'm testing them, or I just want to pump my system out, what we're going to do is say if fuel pump switch state is greater than or equal to 1, so that's if this is 1, 2, 3, or 4, we're going to turn on that lift pump. So this is going to be our basic setup for our lift pump, and in this case, our main pump is pretty much going to use the same logic, but a different output. So our first fuel pump is obviously going to need to turn on as well and have pretty much the same logic as the lift pump. So nothing real fancy here. We're going to leave it all here. Again, the biggest thing here is on your lift pump and your feed pump, you're going to have different typical amperage draws. So make sure you're setting these and make sure your minimum amperage draw makes sense as well, because we'll use that for fault detection. The real trick is going to come here when we start to use more than one pump. We're going to start staging our pumps. So we're going to duplicate this, and because I already had that named Fuel Pump 1, it's automatically going to add my second one as Fuel Pump 2. We're going to move this over to the other side of the board here. And the first thing we're going to do is change this to just is true. So let's just make sure that this pump can only turn on if our ignition switch is on, that there's no weird thing that will force our second pump to turn on. So this is sort of an override kind of thing. And we're actually going to combine that with this. And in this case, we're going to change our RPM. So we're going to do a couple things here. In this case, we're going to stage the pump similar to how we might inside of an ECU when we turn on a second pump, or if we're using something like a Hobbs switch or sort of a mechanical switch like we might have in old school stuff, or some guys actually still choose to use because they're scared of electronics or something. So we're going to kind of do the same thing. We're going to give it a little bit longer false time. And the other thing we're going to do is add a trigger for load. In this case, we're going to use map. So let's say we're only going to need extra fuel if we're, say, over 50 kPa boost. So 158 kPa map, so it's going to be 7.5, 8 pounds of boost. And same thing, we're actually going to give that, it has to be below that for a certain amount of time. So now what we've done is we staged our second fuel pump, and that's the ignition switch has to be on, and the RPM has to be over 2500, and the ECU map has to be above a certain amount. If you have an ECU that does fuel mass load and you can calculate when you need your second pump to turn on, that's a great way to do it. It's a lot more difficult. Not everyone understands that. This is a real simple way, and this is a pretty basic way in how we've done fuel pump staging for a very, very long time. The other thing we're going to do is move the fuel pump. So only when you press the button twice is the second pump going to turn on. In this case, we're staging the pumps, and you can make them work either way, where the switch either turns on only one pump or slowly turns all your pumps on. In this case, when you press it once, it's going to turn off lift pump and pump 1. When you press it twice, it's going to leave those two pumps on and now also turn on pump 2. The next thing we're going to do is going to be where things start to get a little bit more robust, and we're going to start really leaning on the advantages of the PDM here. We're going to have a couple different safeties for this. And the first thing we're going to do is fuel pressure. So even if we're not at the load of the RPM we want, but our fuel pressure is dropping, we obviously want more fuel. The first thing we're going to do is just try to turn on another pump because maybe our first pump isn't able to supply enough or our logic was faulty. So what we're going to do is say if fuel pressure is below, let's say this is a 300 kPa system, let's set it at 280 kPa. And let's give it a little bit of a true delay. We're going to give it a second. And now you can get fancy here and have a table, and the more it is, the less time it has to be below that. And what we're also going to do is make sure that it's over that for, let's give it 5 seconds. So this now says fuel pressure has to be under a certain amount for over a second, and then it'll turn the pump on regardless of what else is going on here. We're also going to add a couple things here. Ignition switch, again, we want that as a function here. And what we're probably going to do is make sure that RPM is also going to be a function here. And we're not just turning this on just because the thing's barely idling or something like that. So we're going to do RPM is going to be over. In this case, we're going to stage a little bit lower, 1500. Something over idle, let's go with 1800. Something a little bit over idle, but not quite our full stage. So in this case, if the engine is running at anything more than 1800 and fuel pressure drops, we're going to automatically go ahead and turn on that second pump and try to recover the fuel. And we'll probably also set some warnings based on this, that if these pumps keep turning on and we don't recover, that's going to automatically trigger something. Now, the other thing we're going to do is if we have a fault on our fuel pump 1, and this is where we're going to really start to use this. So we've got this fuel pump 1 fault here. And this is going to be there has been a problem with fuel pump 1. So if this is true, that means we have a problem. We are going to go ahead and turn on this pump. In this case, if I've had a fault, I'm probably going to go ahead and leave this on for a certain amount of time. In this case, a drift car, something like that, we're going to turn on for 300 seconds. It's going to be about 5 minutes. In most cases, our run's going to be over. Now, this doesn't mean that pump's only going to turn on for that long. That means that if the fault goes away on pump 1, pump 2 will still stay on for that amount of time. That way, an intermittent or fault that's coming and going won't keep coming back, and we'll just leave that second pump on, and we'll trigger a flag, and we'll go look at what's going on and be able to address this after the run, hopefully after we've won that last run. So yeah, we're going to go ahead and turn that on, and we're going to have the same kind of option here. Ignition switch. Typically the ignition switch is off, we won't have a fault, but we're going to go ahead and turn that on as well. So this way, if fuel pump 1 faults, we're going to go ahead and turn that on. We're probably going to also give it an RPM here, again, just to make sure that this pump can't run if the engine isn't running. So we kind of give it the same thing here. So now we've got a couple extra little layers here of this pump. So now it's great, right? So I've got 2 pumps, and my second pump will turn off if my first pump fails. But what if I need 2 pumps to run this car? Now I've got my second pump running, but I'm not going to have enough fuel pump. That's where having this third spare pump comes into play. Now, a lot of people might wonder why you have a dead pump in there you're never going to need. You'd have to wire to it, and that's great. Yeah, it saves you from installing it, but that's not that useful. This is where this really comes in handy. I don't have to go in and change anything. You can have a fuel pump die and have the ECU automatically switch to your third pump. I've had this happen. Driver swears the pump didn't die. It did. This kept him on track. We were able to finish a run, win a run, and stay in there and then address the problem. So just having a spare pump wasn't just about making it easy to switch over. It was seamless. It actually saved our run. So we're going to kind of do the same thing here. In this case, we're not going to stage the pump like we normally do. So we're going to go ahead and remove this function. We are going to have it off state 3. We're going to go ahead and lower this a little bit more. So let's go there. And we will talk about this, that little delay there. Yeah, obviously we want to maintain our target fuel pressure. But what we don't want is the pump constantly switching on because of a little bit of fluctuation. And we want to make sure that there's truly a problem with fuel pressure before we drop that. And this is also why we recommend using what we call 3D injector data, and that's tuning your injector versus fuel pressure, having some sort of fuel pressure compensation. And that will also save your engine. I've also had that happen. If I make sure that I define my fuel injector or make sure I add fuel pressure compensation, which Link has automatically as a checkbox, that my ECU will automatically add the extra fuel if I see a drop versus my base fuel pressure. This is why you should run a fuel pressure sensor. This is why you should tune based off of it. And if you tune like that, that 1 second drop in fuel pressure isn't going to cause a problem as long as you have enough injector overhead. That's also why we recommend giving yourself some injector overhead. So I have room to add 20-30% injector and not go lean. So this will help save it, and this will be smooth. This is a great way to turn on this. So yeah, again, we're automatically going to turn on the third pump if our fuel pressure drops. So we get pump 1 and pump 2 on. If pressure's still dropping, we're going to turn on pump 3. If we've got 3 pumps running and fuel pressure's still dropping, we might have a bigger problem. We do need to address that, but this is one thing to actually try to at least combat that and make it through it. Again, fuel pump fault. We're going to leave fuel pump 1 fault, and we're going to automatically turn this one on. So fuel pump 1 faults, we're going to turn on fuel pump 3. We're also going to do the exact same thing, but off fuel pump 2. So, again, fuel pump, but in this case, 2, fault is true. And let's add that false delay again. And we're again going to add ignition switch. And RPM. In this case, the fuel pump 2 fault, if it's just fuel pump 2 that's faulted, we'll typically probably set this a little bit higher. Yeah, we're going to leave it at 80. So if we're having fuel pump faults, we're automatically just going to not stage the pumps. We're going to have them run all the time. You can get fancy here and stage the pumps and say, oh, if pump 1 faults, pump 2 now becomes 1, pump 3 becomes 2, stuff like that. And that's all possible. It just complicates the logic a little bit. In this case, if your pump's fault, we just want to go ahead and switch to our third pump. We're going to flag it. We're going to take a look at that. This is enough to keep us running. There's not going to be an issue with that. Yeah, sure, it's not as optimized. We might be putting more electrical load on the car than we have, but we should be able to run all these pumps regardless, and this will get us through a run, and that's the goal here. Keep us on track, keep us running, keep us safe, and make sure that we're taking advantage of all the tools we have. This is why a PDM is a lot more than that relay, a lot more than a fuse. There's an advantage here. And if you're not using this, you're giving up some performance advantage, and you're taking a chance you might wind up getting put on the trailer from a mechanical that another team can run through. This will keep you on track. This will keep you winning. This is properly using a PDM. If you need help with this, if you have questions, you have other ideas, if you want to see longer videos and a longer training session of really how to take advantage of a PDM and all the other things you can do, shoot us a message, hit us up. Let us know if you guys want a class about this. We'd be happy to put together a class or a webinar session on this. Until then, have a good one, you guys.